Hi, I'm Phil, and today I want to explore recognizing cars and buses with an AI camera. And we can use the results of this to include the camera in our traffic lights controller. So I'm going to use a AI camera called the HuskyLens, and it comes from a company called DFRobot at a cost of just under $55 US. And what's interesting about it, you can use it quite easily with either the microbit or the Arduino UNO computer. And it already has algorithms for recognizing common objects. And that's what I'm going to use in this case. And luckily, it already can recognize and has been trained to recognize cars and buses. So my project will look at how I can exploit this object recognition function. So I'm going to look at the objective, the hardware, the software, and some of my results. And I'll talk about some of the issues. So I'm not going to do the full integration today. I'm just going to do a unit test on the AI camera. And the main objective is just to recognize if cars and buses are present prior to an intersection. Well, I'm going to use a technique of polling every 2 seconds. And I'll show the IDs of the cars and the buses on a serial terminal on my Windows PC. And as a stretch objective, I want to pass on the IDs to a traffic controller. And the traffic controller can increase the green phase for buses. And if there's a queue of cars, it can also let those cars through on an extended green phase. But I can also get data on traffic density and the queue length. So for the hardware, I'm going to use the HuskyLens AI camera. And it will be coupled to a Arduino UNO computer, which has a Grove base shield. And the HuskyLens will be connected to the Arduino using the I to C port via 2 cables. So I'm just connecting these cables together. The Grove cable connects to the DFRobot 4-wire cable. And for software, I'm just going to use the demo program and just select the right algorithms so that I get detection of the objects. So this is the program from DFRobot at the start, and I'm including 2 libraries, the HuskyLens library, and since on the Arduino computer we only have 1 hardware serial port, and it's going to talk to my PC, I need to create an additional serial port using the software library soft serial. And the main loop is quite simple. All it does is that when it detects blocks, it then prints out on the serial port the identification of the object that it has selected. And if there's more than 1 of those objects, like 2 cars, it will count the cars in that particular polling sweep. So the issues are that it worked quite well. So stay beyond the final slide and I'll give you some demonstrations of what it can do. But it needs to be ported. The whole traffic controller is already saturated and uses almost all the memory on my Arduino UNO computer. So I need a more advanced processor to add on this function. And luckily enough, the code that I've just showed you compiles on that more advanced processor. But the downside is that I would need to rewrite the timer and the scheduler routines because the XEO computer already has a hardware timer, and it won't compile the software timer that I used previously. But luckily enough, there are plenty of examples of using its own real-time clock, and it would take me about an extra day to do this as a new project. So for the references, go to the DFRobot site or the Seed site if you want to do any more exploration. This is the HuskyLens AI camera, and I have it set up in this scene with a Arduino UNO computer, and it's connected to the Arduino UNO via a Grove Shield on the I2C port. So you can see the cable here, and the AI camera has been programmed to recognize up to 20 objects, including cars and buses. And this demonstration will show you it counting the number of cars and buses on this traffic scene. So to put a car on the scene, we'll just put that in front of the camera, and we'll go over to the serial monitor on the PC, and you can see that it's counting that there's how many cars. You can see the number of cars that it's counting, 1 car. And if we replace the car with a bus, we should have a different ID for the bus. So now we've got the bus in front of the camera, and we'll have a look at, it's giving you the parameters for the bus. And that's the HuskyLens AI camera. Let's look at the HuskyLens AI camera counting cars and buses. So the camera, the front of the camera is here, and the lens, there's the lens of the camera. And what we'll do is have a look at the other side of the camera. And we have a LCD screen, and it's currently looking at the cars and the buses, and we'll see if it can identify them. So it's identified, it thinks it's a train. There we are. It's identified the bus as a bus, and if we move around a bit, we hope to be able to identify the car. So we've identified the car and the bus. And how that looks like on the screen, if we look at the screen, we can see that it's identified the bus, and see if we can identify the car. The bus is ID 1, and the car is ID 0. Okay, and that's the HuskyLens AI camera identifying buses and cars. Let's see how good HuskyLens is at identifying cars. So here we have the electric car, the Tesla, and we'll just see the response on HuskyLens. So HuskyLens thinks it's an aeroplane. Let's try a different car. So this time it's taking a Toyota car, and it's recognized the car as the Toyota as a car. So we'll do a few more. So we're showing the result of the camera and the ID process in identifying objects. So it's identified the car, identified another car. So it's not bad, except for the first one. It's identified all these vehicles as cars. Okay, so we might see what it's like with buses. So we'll change the screen now and have a look at some buses. And we'll show those. So for model buses, we'll see if it can identify it. It thinks that simple minibus is a car. And similarly with the next one. But from here on, they look more like bigger buses. And HuskyLens is able to identify this one. The VW, is it a bus or a car? Here it's identified it as a car, but a London bus is definitely a bus, and some older buses. So for most of them it's identified them as cars or buses, but perhaps the majority are buses. Doesn't identify this one. That one's definitely a bus, and the Sydney Explorer is a bus. And that is behind the scenes of the HuskyLens identifying an object. And in this case, the objects are either cars or buses.